Dr. Nikolay Kukushkin challenges the common misconception that evolution cancels out divine creativity. Instead, he argues that evolution amplifies creativity by distributing it through the natural world rather than concentrating it in a single entity. This creative force is reflected in how environmental patterns, like the ocean's influence on seal coloration or skin smoothness, shape biological realities. Evolution, rather than being a mechanical or boring process, injects endless innovation into every aspect of life. He likens natural selection to an intelligence embedded in the patterns of nature, which governs the emergence of biological traits without requiring conscious direction. The creative process is decentralized, inherent to the physical and chemical rules of the environment shaping living organisms. This reframing situates evolution as a dynamic, intelligent force rather than a blind, purposeless occurrence. A groundbreaking revelation discussed is that memory is not confined to neurons or the brain, but extends to other cell types throughout the body, such as kidney cells. Kukushkin's research shows that non-brain cells can form memories using the same molecular and genetic tools as neurons, responding to stimuli in time-dependent patterns and storing biochemical changes that persist beyond the initial cause. This discovery broadens the concept of memory from a strictly neurological function to a universal cellular capability, implying that the body keeps the score in a literal sense. It suggests that trauma or experience might be encoded at a cellular level throughout the body, offering a biological basis for phenomena often described in psychological and somatic therapies. Human uniqueness emerges not from the sheer size or complexity of our brains, but from the capacity to perceive ourselves as distinct from others and to conceptualize this separation. Kukushkin emphasizes that consciousness is fundamentally about this tension, the sensation of being a self separate from other beings and from non-life. This existential divide dissolves when studied scientifically because humans, animals, and even non-living matter exist along a continuous spectrum. What truly distinguishes humans is the brain's ability to hold the idea of self and other as distinct, reflecting a deeper understanding of existence itself. Rather than separating humans sharply from nature, this highlights a continuum wherein awareness is a pivotal evolutionary development. Expanding on this view of distributed creativity, Kukushkin proposes that nature itself can be considered intelligent, depending on how intelligence is defined. If intelligence is seen as any process that leads to rational outcomes, then natural selection and environmental patterning qualify as intelligent systems. He critiques the conventional top-down approach in neuroscience, which begins with human cognition and drills down to molecular mechanisms. Instead, Kukushkin favors a bottom-up approach rooted in biochemistry and cellular processes that scale up to complex cognition and consciousness. This reframing invites a different understanding of intelligence and mind as emergent from fundamental biological and chemical principles. Sea slugs serve as a vital model organism for understanding memory due to their simplicity and evolutionary distance from mammals. Kukushkin explains that while mice are genetically close to humans, sea slugs more accurately represent the typical animal. Their slower metabolism and less complex nervous systems make them ideal for tracing the molecular and cellular steps connecting basic biochemistry to behavior and memory. By studying these simple animals, scientists can better grasp fundamental principles of memory and consciousness without the confounding complexities present in mammalian brains. Sea slugs embody an abstract animal model, helping bridge the gap between single-celled organisms and highly evolved mammals. Memory, even at the cellular level, hinges on temporal chemical patterns rather than spatial or static snapshots. Kukushkin details experiments wherein kidney cells grown in culture respond differently depending on the timing and spacing of chemical stimuli, mirroring the spaced repetition effect well known in human learning. These cells activate specific memory genes in response to these stimuli, and the timing between exposures is crucial for long-lasting cellular change. Such findings propose a universal principle. Biological systems process time-based chemical patterns to form memories across diverse cell types, not just neurons. This molecular perspective naturally leads to implications for trauma research, particularly the idea that the body may store traumatic memories outside the brain. Kukushkin expresses initial skepticism but gradually recognizes that cells throughout the body undergo lasting biochemical changes influenced by stress hormones and neurological signals. This insight aligns with long-standing holistic and somatic perspectives on trauma, like Peter Levine's somatic experiencing, and opens new avenues for understanding conditions like PTSD from a biology-first standpoint. While direct causal links remain to be fully elucidated, the research frames somatic memory retention as a plausible biological mechanism rather than fringe theory. Human memory is not a perfect record of past reality, but rather a dynamic reconstruction shaped by impression and utility. Kukushkin rejects the notion that episodic memories function like snapshots stored in the brain. Instead, memories are persistent changes in neural configuration based on experience that serve future adaptation. This reinterpretation highlights why memories are often fallible or malleable. They are not awaiting excavation, but constantly shaped by ongoing neural processes and subsequent experiences. Procedural memories, such as muscle memory for playing piano, form chunks of muscle control encoded in basal ganglia circuits, demonstrating memory's diverse forms and brain localization. Contrary to popular belief, dopamine is not a pleasure chemical, but rather a surprise or learning signal. It flags unexpected positive events and motivates the brain to investigate and make these events predictable in the future, thereby reinforcing behavior to access rewards efficiently. Experiments with pigeons show that unpredictability sustains dopamine-driven motivation. Randomizing rewards triggers persistent, compulsive work more than fixed schedules. Kukushkin explains dopamine as a finite resource, akin to a daily salary, expended during unexpected events and needing replenishment. This framing elucidates addiction and modern phenomena like social media's hold. Kukushkin traces humanity's gradual outsourcing of cognitive functions, from oral memory to writing, from radio to television, and now to digital devices and artificial intelligence. While these technologies can enrich information access, they also compete for memory and attention, often diminishing our capacity for sustained concentration and deep learning. The brain's memory capacity is nearly saturated in the modern world, resulting in constant overwriting and difficulty distinguishing valuable from trivial information. Sleep deprivation exemplifies this breakdown, leading to hallucinations and memory blending. The rapid pace and novelty bombardment of digital technology heighten these challenges, posing risks to intellectual depth and mental well-being. Kukushkin envisions human evolution extending beyond biological constraints through integration with technology, suggesting the emergence of an expanded, possibly hive-like intelligence. Just as early single cells combined into multicellular organisms to create new forms of complexity, modern humans might fuse cognition with AI and digital networks to transcend current limitations. While this trajectory may compromise individual creativity and language mastery, there might be collective gains in intelligence and problem-solving capacity. This speculative future raises concerns about the loss of essential human faculties, but also opens possibilities for unprecedented cooperation and cognitive augmentation. Finally, Kukushkin bridges scientific understanding with existential meaning, suggesting that consciousness and life's patterns provide an origin story that imparts purpose without invoking supernaturalism. He interprets science as a disciplined quest for truth that uncovers nature's essences embedded in matter, patterns, and processes like carbon-oxygen metabolism. This scientific worldview can coexist with awe, reverence, and faith, as it reveals a universe unfolding through consistent laws while inviting personal significance. Kukushkin identifies awe as the best drug or experience, evoking humility and wonder towards existence. His perspective offers a middle ground where science and spirituality converge to enrich human understanding and belonging.